Good afternoon, everyone. So let's have a brief introduction of each other so that I can got to know about the people who have joined. So my name is Asma Parveen. I am a PhD scholar at in Civil Engineering Department at IIT Kanpur. I am one of the TA for this course. This course is being taught by Professor Vanu Prakash Velanki from IIT Roorkee. So thank you. Now we can have introduction of 30 seconds of each of the participant. So so can we start with Sudarshan Veera? So I think he is not available. So can we go to Vaishnavi Gulhane? Can you please give a brief introduction about yourself?
Good afternoon, ma'am,
Good
and
afternoon.
good afternoon, everyone. My name is Vaishnavi Gullane. I'm a research scholar from VNIT Nagpur. I'm in first, is now just gone to second year in environmental engineering.
So you are a master student or a doctoral
A
student?
PhD
PhD.
student,
Okay, okay.
second year.
Okay, thank you, Vaishnavi. So can we
Thank you.
move to Jenny? So I think Jenny is also not available. So can we move to Balaji Rajamani? Can you please introduce yourself?
Tech in chemical engineering. I'm now currently working as a process engineer in water and wastewater treatment field.
Okay. So Balaji, there was some problem. So Balaji, there was some problem. Can you please introduce yourself once again because I was not able to hear.
Hello,
Yes.
am I audible, madam?
Yeah, yeah. Now you're audible.
Good afternoon to everyone. I'm Balaji. I completed BTech in chemical engineering and I'm currently working as a process engineer in water and wastewater treatment field.
Okay. Okay. Thank you. So now I'll share my screen. So welcome everyone to the week 2 problem solving session for the course Environmental Chemistry, instructed by Professor Bhanu Prakash Velanki from IIT Roorkee. So in this session we are going to discuss about the previous year second week assignments followed by some questions, additional questions added by me from the reference book. So first there is a brief introduction, or I can say a summary for the previous week. I hope everyone has gone through the lectures. So lecture 6 was about component balance. So sir introduced about what are species, components and how to approach the problems based on component balance. So for any reaction at equilibrium, all the compounds involved in that reaction is species, and components are the building block for any reaction. So components are the minimum number of species which can define the whole system. And while solving any component balance questions, first we have to identify the species, and then we have to identify the components, and then we write the all the known reaction equilibrium reactions. Then we try to find out if the system is consistent or not, and we see the number of whether the number of equations we have is equal to number of the unknowns. In also the formation reactions, we do the mass balance for all the components involved in that system. And then lecture 7 was about kinetics. So in one thing is thermodynamics and the other is kinetics. Thermodynamic tell us about whether a system is feasible or not, whether a reaction is feasible, it will go from left to right or right to left, and what will be the rate or speed of that reaction we got to know about from the knowledge of kinetics. So if we have a number of reactions or number of elementary reactions or a number of sequential reaction, then among all the reaction, one reaction will have the uh, uh, least kinetics, or I should say will have the slowest kinetics, and that step will be the rate limiting step, and because overall kinetics of the system will be determined or will depend upon that step. And in the next lecture, lecture 8, there was again Tosser talked about rate of reaction, in which he talked about factors affecting the rate of reaction. So there are basically two factors: concentration of reactant and temperature. In concentration of the if the concentration of the reactant is increased, then the rate of reaction increases. And based on the concentration of reactant and the stoichiometry of the reactants involved in the reaction, there is rate of reaction 0 order, first order and second order reaction. But for elementary reaction, the rate of a reaction depend upon the stoichiometry of the reactants. But if the reaction is a complex reaction, then it is not necessary that rate will depend upon the stoichiometry of the reactants. It can be different depending upon the reaction. Next is temperature. Based on the temperature, the rate of the reaction changes, and there was one equation called Arrhenius equation which relates the rate kinetics at two different temperature. In the next lecture, there was a continuation of rate of reaction followed by types of reactor. So the first two slides I think was based on how to solve a complex set of reactions followed by the types of reactor. So basically we have three types of reactor: batch reactor, plug flow reactor and continuously stirred tank reactors. So in batch reactors, we just add the required amount of solvent or the solution. And then the reactor is closed and the reactions are taking place inside the reactor. There is no inlet and outlet until the reaction is complete in that reactor. Then we have the plug flow reactor, in which there is no longitudinal mixing of the components, there is only lateral mixing of the reactants or compounds in that reactor. Then there is continuously stirred tank reactor, which is a continuous reactor with the continuous mixing taking place in the reactor. And in the last lecture, it was discussed about how to do the mass balance on these different types of reactor. So now we will move to the assignment questions and we will try to solve the questions. So it will be like previous week. I will give you a question. I will give you 1 minute or 2 minutes based upon the how much lengthy is that question, and then we will whoever gets the answer, just write your option or values in the chat box so that I get to know that you have solved the question, and then we will see the solution for the question. So first question is, consider the dissolution of sodium bicarbonate in water. Species at equilibrium for the above solution are, species are given, and we have to find out which of the following groups can be chosen as component for the formation reaction. An additional comment is given that one or more options can be correct. So we have been given the list for the species and we have to find out of these four options which of the options represent the component for the system. So I will give you guys 1 minute. So just it is a pretty straightforward question. There is no need for calculator or anything. So just think and write your option in the chat box. So I got only one answer as B and D, but sorry, as A and B, but A and B are not the correct option. So out of these species, if we take H plus, Na plus and carbonate, then these three represent the component as through H plus we can represent OH minus and H2O. Since Na plus is the single species, so we need Na plus in the component, and from carbonate we can describe its all three forms, that is H2CO3, bicarbonate HCO3 minus, and carbonate, that is CO3 2 minus. So option B is the correct option. And if we take C, then it has one different species H plus, and next is um, carbonic acid and bicarbonate. If any one of these would have present, then it would represent component, otherwise these two are the species. And if you see the last option, we have Na plus, bicarbonate species, and OH minus, then bicarbonate will represent all the three species of that. OH minus will show H plus and H2O, and Na plus will show Na plus. So answer B and option B and D are the correct options. So we'll move to the next question. So I hope is it clear, or anyone have any doubt? So let's move to the next question. So let me rub this. So so next question is also a similar question. So we have sodium acetate is dissolved in water to undergo the following reaction. From sorry, following details were obtained after analysis. We have been given the species and components. Choose correct options. One or more can be correct for total concentration of components. So we have to find out the total concentration of the components, that is Na plus, H plus, and Ac minus. So these four options are given. We have to tell which of these is correct. There can be more than one options that is correct. So I'll give you 1 minute. Just take your time and write your option in the chat box. didn't get any answer, so let's see the correct options. So for Na plus, Na total would be equal to the concentration of Na plus, because there is no other species for sodium, and total acetate concentration would be sum of the acetate HAC and HAC minus, and total H plus concentration or hydrogen concentration would be HAC, because H is present in AC, then H plus minus OH minus. So here there is minus OH minus because H2O dissociates as H plus and OH minus, and when we write the concentration of OH minus, it is H2O minus H plus. So here one H plus is subtracted from H2O, then we get OH minus. So overall H plus concentration would be sum of concentration of HAC and H plus minus OH minus. So H plus has no relation with AC minus and Na plus. So as there is no H in both the compounds, so first option is wrong, and all three are the correct options. So we'll discuss the next question. Sequential reaction occurs in the following three-step process. We have been given a reaction going A giving B, B to C and C to D, and we have been given the relation between K1, K2 and K3. Which step is the rate determining step for the above reaction? So we have to tell which step is the rate determining step. So four options are given: first, second, third, or both first and third step. So I'll give you all 1 minute. Please try to solve this question and write the option whichever you are getting in the chat box. So correct option is B. So I got two answers as B and one as D. So the correct option is B, because we can see the relation between K1, K2 and K3. K1 is 100 times of K2 and K3 is also 100 times of K2, and if you see for K2, K2 is 1 by 100 times of K1 and 1 by 100 times of K3. So K2 is the slowest step, and so the second step from B to C would be the rate determining step. So here is the explanation for this, that the rate determining step is the slowest step in series. K2 is smallest, and hence second step is the rate determining step. So we'll move to the next question. So here we have to tell which of the following statements are or is correct given, consider given reaction below. A reaction is given going from A to B. It is a reversible reaction. So the options are, for the reaction to be irreversible from A to B, RB has to be much greater than rate of reaction RA. For the reaction to be irreversible from A to B, RB must be much lesser than RA. The rate determining step is the slowest step in series, and D, the rate determining step is the fastest step in series. So option A and B are related to the reaction which is given, and C or D are the general statement which we have just now discussed in the previous question. So we have to find out which are, out of these four, how many are the correct options. So I'll give you all 1 minute. It is a pretty straightforward question. So just take your time and write your options in the chat box. So there are three. So 3% have texted in the chat box. The two are saying that B and C are the correct option. So let's see. So RA and RB here shows the rate of formation of compound A and B respectively. So for any reaction to be irreversible from A to B, the rate of formation of B must be much greater than A. So RB should be much greater than A. So, and the rate determining step is the slowest step in the series. So the correct options are A and C. So if anyone have any doubt in between, you can just unmute yourself and ask. So let's move to the next question. So it is a numerical based question. 1 gram of solid calcium sulfate is added to 1 liter of pure water. Some of the solids then dissolve according to the following reaction, which has the equilibrium constant of this. The concentration of Ca2 plus at equilibrium is the concentration of Ca2 plus at equilibrium, we have to find this. Find the value of X. Also assume concentration of sulfate at equilibrium as 10 to the power minus 1.87 moles per liter. Take activity is equal to concentration for all compounds. So I think it is a very straightforward question in which we have been given the equilibrium constant, we have been given the concentration of sulfate, and we have to find out the concentration of calcium. So I will give you all 2 minutes. Just solve this question and write the value which you are getting in the chat box. So I request everyone to please try to solve these questions, because it will help you to solve the present assignment questions which are given, and also the written exam which you will be appearing at the end of the course. So take your time and write the value whichever you are getting in the chat box. So I am having some network issues, so I request everyone to just wait for 2 minutes. how to solve this question. So we have been given the equilibrium constant of the reaction. So as we know, equilibrium constant is the ratio of activities of species in product to the ratio of activities in the reactant side. So as we know, for any solid its activity is 1, so it would be 1. So equilibrium constant would be activity of Ca2 plus into activity of SO4 2 minus, and in the question it has been given that we have to take the activity as concentration, that so it says that the system is dilute, so K would be concentration of Ca2 plus into concentration of SO4 2 minus. So we have to take the concentration of Ca2 plus as minus X, and we have been given the concentration of sulfate as 10 raised to the power minus 1.87, and K is 10 raised to the power minus 4.85. So after solving this, we will get X as 2.98. So 2.98 is the correct answer. So if anyone have any doubt, you can ask, or we can move to the next question. Okay. So let's move to the next question. It is also a numerical based question. The question says, a study that investigated the reaction of bisphenol A with hypochlorous acid revealed that even if all the BPA reacted, hypochlorous acid would decline very less and could therefore be treated as approximately constant under the experimental conditions. So we have been given the reaction that bisphenol A, that is in short BPA, is reacting with hypochlorous acid HOCl, and it is giving some product. And as per the question, the concentration of HOCl is much more than the concentration of BPA, that is HOCl is consumed very less in the reaction, so it can be treated as constant. So the rate expression can be described as rate of formation of BPA, or since it is declining, or loss, so Kf, concentration of BPA raised to the power of A, and HOCl raised to the power of B. And we have been given the initial concentration of 0.3 millimolars total BPA and 0.3 micromoles per liter total BPA and 18 micromoles per liter of total OCl at pH 8, and Kf is 150 liters per mole second. How much time would be required to destroy 75% of the BPA in this solution? So we have to find out the time in which 75% of the BPA would be consumed in this reaction. So we can see that from the reaction nothing is mentioned about the stoichiometric coefficient. So we will take A as 1 and also B as 1. So rate of BPA formation would be minus Kf, concentration of BPA into concentration of HOCl, and this question is based on pseudo first order reaction, in which out of the two reactants taking part in the reaction, out of these two, one concentration of one of the reactants declines at a very smaller rate as compared to the other. So we treat the reaction, this reaction, as a pseudo first order reaction. So we have been given the rate of formation of BPA, and we know the concentration of OCl. HOCl is declining very slow, so we can treat HOCl as constant. So by taking the concentration of HOCl as 18, we will get a new equilibrium constant, and by putting that equilibrium constant, we can find out how much time is required for destroying 75% of the BPA. So I request you all to please solve this question. I will give you all 3 minutes to solve this question and write your value. So if anyone needs any extra information, I can give, so that you can try to at least try to solve this question. So I'm not getting any response from your side, so it is a request to please participate while solving this question, because it will help you to try solve the assignment questions, and also, as I told you, it will also help in the written examination in which you will be sitting. So I'll give you one more hint for this question, is that we can find the rate of BPS minus KF, whatever it is given, it is 150. BPA, it's declining, but 18 micromoles per liter is constant. So by multiplying these two, we will get a different K value into BPA. So now we can see that this question has shifted to a first order kinetics, where rate of formation of BPA is K times the concentration of BPA. So now the question is a simple mathematical problem. You just have to integrate this question to find out the final expression which will be used, and in that expression you have to put the values of BPA and K, and you will get the time. So I will give you all 3 minutes, so please try to solve this question, and we will see how to solve it. So we'll see how to solve this question. So after multiplying minus 150 and this, we would get as minus 0.0027 into BPA concentration. So it is a problem of ds by dt equal to minus kt, sorry, minus ks. So ds by s equals to minus kt. After integrating, we would get log, if we take s naught at time t equals to 0 and s as time t equals to t, then after integrating we will get s naught to s is minus kt 0 to t. So overall it would be log s by s naught equals to minus kt, or by taking further solving it would be s equals to s naught e to the powers minus kt. So after solving we will get the final expression as this. So we would have concentration L and concentration of BPA at any time t to the initial concentration times minus 0.027 into t. So we have to find out the time, and we have to find out the time at which around 75% of the BPA is destroyed. So only 25% will be present in the solution. So we would have 0.25 of initial BPA concentration so after solving all these we will get the time as 513.442 second, and after converting it into minutes we will get the time as 8.5574 minutes. So we have got the unit as second from the formation constant, which is given as 150 liters per mole second. So while solving this question we have to see what is the units given for the concentration and the equilibrium constant, and from that we will find what will be the unit for which we have to find out. So we'll move to the next question. So it is a objective type question in which we have to find out which of the following class of reactors can be used to model calculation of 5-day BOD of wastewater in a beaker in the laboratory. A. Plug flow reactor, batch reactor, or completely mixed flow reactor. So we do BOD test for wastewater, and we have to say what type of reactor is that. So it is a very straightforward question, so I will give you guys 30 seconds. Just write your answer in the chat box. So B is the correct option, batch reactor, because what we do in BOD test is we take some amount of wastewater, we add the chemicals in that, and then we cover the BOD bottle with its stopper, and we put that bottle in the incubator. So there is no inflow outflow, there is no mixing taking place. We only mix the reactor or bottle initially, and then we just keep it in the incubator. So it is a batch reactor type. So we'll move to the next question. Consider the following reactions occurring in a reactor. We have been given the rate of reaction for the first reaction and for the second reaction. What will be the net rate of formation of C? So C is involved in reaction 1 and 2 both, and we have to write the rate of formation of C. So it is also a straightforward question, so I will give you all 1 minute to just see which option will be correct and write your answer in the chat box. So D is the correct option. So if we see the first reaction, there is formation of C. So and the stoichiometric coefficient is 2, so it will be 2R1. And in the second reaction, there is destruction or loss of C, so it will be negative, and 3 moles of C are consumed for 1 mole of the reaction, so it will be minus 3R2. So the overall rate of formation of C would be 2R1 minus 3R2. So here the explanation is given that rate of formation in the first reaction is 2R1 and in the second reaction is 3R2, and for the overall reaction it will be rate of the forward minus rate in which there is formation minus rate in which there is loss, so it would be 2R1 minus 3R2. So this question is a numerical based question. The question says a batch reactor is operating to treat a toxic chemical S present in water. The initial concentration of chemical X was found to be 500 milligrams per liter. The concentration of X shall be removed to a desirable limit of 10 milligrams per liter in water. Calculate the rate constant if the desirable limit is achieved in 10 days. So we have to find out which is the correct answer. So it is a very straightforward question. We just have to find out the rate constant. Initial concentration is given, final concentration is given, and the time in which that concentration is going from initial to final is also given. So we have to find out the rate constant. So I'll give you all 3 minutes. Take your time and try to solve this question. got one answer as B, and B is the correct answer. So let's see how to solve this question. We have been given a batch reactor, and for a batch reactor the expression is so this is the expression for reaction taking place in a batch reactor, and we have been given x, we have been given x naught, we have been given t, and we have to find out k. So ln x by x naught, by taking log, natural log on both sides, we will get this expression, and k would be so we have so we will get some value as 0.3912 per day. So if we see the unit for k, here milligrams per liter will be cancelled out, and here it is 10 days. So the unit for k will be per day. So we'll move to the next question. So we have to select the correct statements. There are 4 statements given. A, diffusion phenomenon occurs due to concentration gradient. B, advection phenomenon occurs due to net motion flow of carrying fluid. Or C, only longitudinal mixing is considered in advection during modeling of a plug flow reactor. Or D, only lateral mixing is considered in advection during modeling of a plug flow reactor. So we have to find out which of these statements are correct. So there are one or more than options which can be correct. So I'll give you all 1 minute to just see the question and find out which of these options are correct. So I got one answer as A, B and D. Let's see what is the correct answer. So A, B and D are the correct option. So the only wrong statement is C, which says that only longitudinal mixing is considered in plug flow reactor, but in plug flow reactor there is no longitudinal mixing, only lateral mixing is there in the plug flow reactor. So we will see some additional questions based on week 1 and week 2 material. So here is a numerical. Natural water has a dissolved organic carbon concentration of 3.5 milligrams per liter. The average composition of the organic molecules in the solution is this. Assume that all the molecules actually have that composition. Compute the molar concentration and mass concentration of the molecules in the sample. So it is a simple conversion question in which we have been given the total concentration of DOC. We have been given the what is the formula for that compound, and we have to find out the molar concentration and mass concentration. So I'll give you all 3 minutes to solve this question. Just write whatever value you are getting in the chat box. So I'm getting 9.722 micromoles. 5.036 micromoles per liter is not the correct answer. So we'll see how to solve this question. We have been given the concentration of dissolved organic carbon as 3.5 milligrams per liter. First we'll find out the molecular weight of the organic compound which we have been given. C30, C30H, 33 and O18N. So the overall molecular weight would be so it would be 695 grams per mole. So now it is we have 30 into 12 grams of carbon in 695 grams of this organic compound. So we will get 3.5 milligrams per liter in 695 by 30 into 12 into 3.5, and the overall value would be 6.757 milligrams per liter. Now we have to find out the molar concentration. So as we know, molar concentration is ratio of number of moles per liter of the solution. So we will find out the number of moles as 6.757 divided by 650. Sorry, it is 695 is the molecular weight. So we will get these as 9.722 into 10 to the power minus 6 moles per liter, or 9.722 micromole per liter. I hope this question is clear to everyone. So if anyone have any doubt, then you can ask. Otherwise we will move to the next question. So let's move to the next question. So it is also numerical. A solution is reported to have a total hardness of 4.5 milli equivalent per liter. If 80% of the hardness is contributed by Ca2 plus and other 20% by Mg2 plus, what are the concentration of Ca2 plus and Mg2 plus in milligrams per liter? It is a simple question. We just have to convert the milli equivalent for calcium and magnesium in milligrams per liter. We have solved similar question in the previous week session. So I hope you all would be able to solve this question. So I will give you all 3 minutes. Just take your time and write whatever value you are getting in the chat box. So let's see how to solve this question. We have been given that out of the total hardness, 80% is contributed by calcium and 20% by magnesium. So we have 80% of calcium and 20% of magnesium. Now we just have to convert the milli equivalents to milligrams per liter. So as we know, milli equivalents is given weight to the equivalent weight, and for calcium we have to find out the given weight. Let okay assume it to be W1. For calcium, equivalent weight will be 40 by 2, because charge on calcium is 2 plus, so Z for calcium will be 2, and we have been given the milli equivalent as 3.6. So after solving, we will get given weight as 72 milligrams per liter. I hope this part is clear. Similarly, we will find for magnesium. We have been given 0.9 milli equivalents. We have to find out W. Equivalent weight for magnesium will be 24, that is atomic mass of magnesium divided by 2, and we will get W as 10.8 milligrams per liter. So if we see for the units, so it is given in milli equivalent. If we convert it to equivalents, just divide it by 1000, and we will to convert into milligrams, we will multiply by 1000. So overall, this 10 to the power minus 3 and this 10 to the power plus 3 will cancel out, and we will get the weight in milligrams per liter as 10.8. So if anyone have any doubt, you can just unmute yourself and ask, or otherwise we'll move to the next question. So let's move to the next question. Benzene, toluene and ethyl benzene and xylene, which is in short termed as BTX, are common constituents of gasoline. Vapor pressure of pure liquids are given. Assume an equimolar mixture of these liquids obeys Raoult's law. Calculate the pressure exerted by each chemical and the total pressure exerted by the mixture. So I will state what is Raoult's law. So as per Raoult's law, vapor pressure or partial pressure for each constituent in the mixture would be mole fraction of that constituent into total pressure. So in the question we have been given the vapor pressure of pure liquids, and each liquid concentration of the liquids are equimolar. So if we have 1 molar of benzene, then 1 molar of toluene and 1 molar of other two. So if we take the overall moles as 1, then benzene contribution will be 0.25 and toluene will be 2.25 and so on. So we have to find out the pressure exerted by each chemical and the total vapor pressure exerted by the mixture. So from the Raoult's law, vapor pressure exerted by each is equivalent to mole fraction into the partial pressure of that component in the pure liquid form. So Just I'll give you 3 minutes to solve this question and write the answer in the chat box. Okay, let's see how to solve this question. So as per Raoult's law, the vapor pressure exerted by the vapor pressure of the solution is equal to the mole fraction of the solvent into the vapor pressure of the pure solvent. So if we have to find out for benzene, then we have to find out the mole fraction for benzene. So we have been given the equimoles for each. So if we consider 1 mole, so I have used initial terms B, T, E and X to show the benzene, toluene and other elements compounds present in the solution. So we have equimolar. So if we consider the total moles as 1, so each compound moles would be 0.25 moles. So here the mole fraction is number of moles of the solute to the total number of moles in the solution, that is 1, into vapor pressure of the pure benzene, which is given as 0.126. Similarly, we will find for toluene. Again, the vapor pressure would be 0.25 by 1 into 0.038. For ethyl benzene, it would be 0.25 by 1 into 0.0126. It is the vapor pressure of pure liquid. And then xylene, which would again be equals to 0.25 into 0.0117. So after solving benzene, we will get 0.0315. For toluene, the value is 0.0095. Ethyl benzene, it is 0.0032. And for xylene, it is 0.0029. So now next part says we have to find the total vapor pressure exerted by the mixture. So total vapor pressure would be the sum of the pressure exerted by the each constituent. That is, for benzene it is 0.0315, then for toluene it is 0.095, then for ethyl benzene it is 0.032, and for xylene it is 0.0029, and we will get the total vapor pressure as 0.047 atm, because the pressure initially is given in atm, so the unit for the vapor pressure for each constituent and for the overall vapor pressure would be atm. So let's move to the next question. If anyone have any doubt, then you are free to unmute yourself and ask the doubt. So it is a question based on ionic strength. We have also solved similar question in the last week session. So we have been given the concentration of NaCl, sodium sulfate and magnesium sulfate. These are the three salts. All these salts dissociate completely, so the resulting solution only contain their ions in addition to H2O. So we have to compute the ionic strength of the solution. So A, B and C, these are the three different solutions. So we have to calculate ionic strength for each solution differently. So I'll give you all 3 minutes. It is a very straightforward question. So just take your time, do the calculation and write your answer in the chat box. So let's see how to solve this question. As we know, ionic strength is half summation of Ci Zi square, where C is the concentration and Z is the charge. So for first solution we have only NaCl, and NaCl will dissociate completely, and Na plus and Cl minus. So in the solution we will have Na plus and Cl minus. So ionic strength will be half Ci, that is 0.05, charge is plus 1 square, plus 0.05 into minus 1 square. So it will be around 0.05 m. And again for Na2SO4 sodium sulfate, we will get 2 Na plus and 1 SO4 2 minus. So the ionic strength would be half of now 1 mole of Na2SO4 will give 2 moles of sodium and 1 mole of sulfate. So 2 into 0.025 into charge is plus 1 plus 0.025 into charge is minus 2. So we will get this as 0.075. So this is for B, and for C we have MgSO4. So 1 mole of magnesium sulfate will give us 1 mole of magnesium 2 plus and 1 mole of sulfate ion, and the ionic strength would be half. Concentration of magnesium would be 0.025 into charge is plus 2, and for sulfate also it will be 0.025 into minus 2 square. So we will get the ionic strength as 0.1 m. I hope this question is clear to everyone. So let's just move to the next question. So we have been given a natural fresh water is modeled as a solution of 10 raised to power minus 3 molar NaCl, 10 raised to power minus 3 molar NaHCO3, and 10 raised to power minus 4 molar CaCl2. Assume that when these salts dissolve, they dissociate to Na plus, Cl minus, Ca2 plus and HCO3 minus, and then do not react further. Find the ionic strength of the solution, and next, what is the activity of each dissolved ion if the infinite dilution reference state is used. So just now in the previous question we have calculated the ionic strength of the solution, and in this question also we have to calculate the ionic strength. So I hope everyone would be able to solve this question. So I'll give you all 3 minutes. Please solve the question and write the value in the chat box. I got one answer as 2.3 raised to 2.3 millimolars. So this is the correct answer. Let's see. It is also a straight question like previous one. So each mole of NaCl will dissociate and give us 1 mole of Na plus and 1 mole of NaCl minus. And sodium bicarbonate, here it is mentioned that it dissociates as sodium ion and bicarbonate ion. And for CaCl2 we will have 1 mole of calcium and 2 moles of chloride. So now just we have to put the values. So 10 raised per minus 3 moles of NaCl. So ionic strength is half summation Ci Zi square, where C is the concentration and Z is the charge. So sodium is 1 mole of sodium from here and 1 mole of sodium from here, and there is 10 raised per minus 3 moles of NaCl, and also sodium bicarbonate is the concentration is same, so we will have 2 into 10 raised per minus 3 moles into charge is plus 1. So next we will see for chloride, we have 3 moles of chloride, 2 from CaCl2 and 1 from NaCl, and from NaCl we have 10 raised per minus 3, and from CaCl2 we have 2 into 10 raised per minus 4 into the charge, that is minus 1 square. And next we have calcium Ca2 plus, that will be 10 raised per minus 4 into plus 2 square. It is also done. Now we have bicarbonate. Bicarbonate is also 10 raised per minus 3 into minus 1 square. So I hope this question is clear to everyone. So let's move to the next question. So this will be the last question for today's session. The question says the reaction for the dissociation of water is shown below as it is conventionally written. H2O dissociates in H plus and OH minus ions. The equilibrium constant for this reaction is 10 to the power minus 14 at 25 degrees centigrade, and the standard molar enthalpy of the reaction is 55.81 kilojoules per mole. Compute the equilibrium constant for the reaction at 4 degrees centigrade and determine the activity of OH minus ions in equilibrium solution at 25 degrees centigrade and 4 degrees centigrade if activity of H plus is given to be 10 to the power minus 7 in both solution. So in this question we have been given the equilibrium constant at 25 degrees centigrade, and we have to find out the equilibrium constant at 4 degrees centigrade. So we will use the Arrhenius equation mentioned by sir in the lecture, which says log K2, or we can say the equilibrium constant at temperature T2 to K at T1 equals to enthalpy of the reaction delta H by R gas constant into 1 by T1 minus 1 by T2. So in this question we have been given K at 25 degrees centigrade as 10 raised power minus 4. We have been given delta H as 55.81 kilojoules per mole. We know R is 8.314 joule per Kelvin per mole, and we have been given T1 and T2. T1 is 25 degrees centigrade, we will convert it into Kelvin, and T2 is 4 degrees centigrade, we will convert this also in Kelvin, and we will put all these in the equation and we will get the value of K at 4 degrees centigrade or K at temperature T2. So I will give you your 3 minutes. I have given you the idea to solve this question. You just have to put the values in this equation and you will get the value of K at 4 degrees centigrade. And next, after getting K2, we will find out the activity of hydroxide ions at 25 degrees centigrade and 4 degrees centigrade. So take your time and write the answer in the chat box. So I got one answer, and that is the correct answer, that Kw at 4 degrees centigrade will be 1.8 into 10 raised to power minus 15. So we will see, we just have to put these values in the equation. After solving this, we will get the K as 1.8 into 10 raised to the power minus 15. So in kelvins it will be 298 Kelvin, because to convert the Celsius into Kelvin we add 273, and again 273 plus 4 will be 277 Kelvin. So the next part says we have to find out the activity of hydroxide ion in both the situation at 25 degrees centigrade and 4 degrees centigrade. So first we'll find out at 25 degrees centigrades. We will have, according to this, Kw will be activity of H plus into activity of OH minus divided by activity of H2O, and we know that activity of H2O is 1, so Kw would be activity of H plus and into activity of OH minus. So at 25 degrees centigrade we have Kw as 10 raised to power minus 14, and in the question it is mentioned that activity of H plus in both the at both the temperature is 10 raised to power minus 7, so we will get the activity of OH minus as 10 raised to power minus 7. And in the next question we have next part, actually at 4 degrees centigrade we just now calculated Kw as 1.8 into 10 raised to power 15, and that would be equal to activity of H plus, that is 10 raised to power minus 7, and we have to find out the activity of hydroxide anion. So after solving this we will get the activity of OH minus as 1.8 into 10 raised to power minus 8. So we can see that with change in temperature the activities of the H plus and OH minus have changed. So temperature also plays role in the reaction kinetics. So these are the questions for today. If anyone have any doubt you can ask me, and I am seeing that there is very less participation from your side, so I want to ask, if are the level of question very high or you all have not seen the lecture, because only 1 or 2% are solving the questions, and this is not enough. So any one of you can unmute yourself and just say whether the questions are too tough or there is some other problem. So someone messaged the question level is very difficult. So the question number 1 to 10 was the previous year assignment, and the level of question which is given in the assignment. So expectation are this, that the question in exam will be of the same level. So if you are having problem in solving those questions, then I will suggest you to just go through the lectures, and if while watching the lecture if you are having any doubt, then you can do one thing, that you can post your questions in the NPTEL portal. There is one section where you can, there is a section called ask a question, where you can ask your doubt, So the team members from the course will try to sort out those doubt, and also in the live sessions you can ask your doubt. I'll try my best to solve your doubts, and the additional question which I am adding are also from the reference book which the professor has suggested in the first lecture, I guess. So if you think the level is very high, so what I will do is I will try to give the insight of what is being given in question, and what is and how we will solve the question that I am already given, but I will try to explain it more in the coming weeks. And I've got one message. Okay, someone messaged that she is traveling, so no problem. I just want to request you all to please participate while solving these questions, because by solving this question it will eventually help you in solving the current assignments and also in the end semester. So thank you so much for joining. Have a nice day. Thank you.